Good morning everyone. Well, myself Dr. Rajeshwari HV, working as an assistant professor in chemistry JSS College, Goka. In the previous video, I had discussed about the second law of thermodynamics and the different ways of stating the second law of thermodynamics and what is a spontaneous process and non-spontaneous process. With this, in this video, let us understand the concept of entropy. So entropy is basically a thermodynamic property. It is represented using the symbol capital S, and the change in entropy is represented using the symbol delta S. And entropy is one of the important thermodynamic property, and it is defined as entropy is a measure of disorder or randomness of the system. And the keyword here is disorder or randomness. Now let us understand the meaning of disorder or the randomness. So with respect to states of matter, we know solids, liquids and gases, the states of matter. The molecules in case of solids are in the fixed position. The disorder or the randomness of the molecules is less in case of solids. Whereas in case of liquids, the molecules can move within the container. The liquids will take the shape of the container. It is not in a fixed position. Whereas in gases, the molecules move in all the directions. Now, if the question is asked, where exactly the randomness is more? So, definitely it is gases. The randomness is more in gases, then it is liquids, then the least is solids. So, entropy is a measure of disorder or randomness of the system. Now, the second important property of the entropy is a state function. What is state function? If the function depends on the present state and the initial state, that is the state of the system, then we call that as state function. So delta S, that is change in entropy, is equal to the final state minus initial state. So S2 is the final state and S1 is the initial state. So for example, if you have a two variables, volume along the y-axis and pressure along the x-axis, if S1 is the initial state and S2 is the final state, so we have a two paths here, that is path 1 and path 2. So that is initial state can reach the final state either using path 1 or path 2, but the entropy only depends on the initial state and present state. It does not depend upon the path used by the system. So that is the meaning of state function. If any property depends on the present status of the system, present state of the system, then we call it as state function. That's why entropy is a state function. It depends on the initial state and the final state. It does not depend on the path used to bring about the change. Now the second point in entropy, third point is entropy is an extensive property. Entropy is an extensive property, means it depends on the amount of the substance. Extensive means mass, volume, all these are example for the extensive property. If it is intensive property, surface tension, viscosity, these are the intensive property. Since entropy depends on the mass or the volume, it is an extensive property. Then the next point is, in an adiabatic process, delta S, that is change in entropy, is equal to 0. So well we know what is an adiabatic process. It is a process in which the heat is not absorbed between the system and the surrounding. There is no exchange of heat between the system and the surrounding. Then such a process is known as an adiabatic process. So that is, entropy change is always accompanied by absorption or liberation of the heat. Since in case of adiabatic process, the entropy change is 0, say because the heat is not absorbed between the system and the surrounding. Because according to the expression delta S, that is change in entropy, is equal to Q subscript R divided by T, then Q is equal to 0. In adiabatic process, Q is equal to 0, then expression becomes delta S is equal to 0. Now, for an isothermal process, we write the expression a change in entropy is equal to Q subscript R divided by T, where T stands for absolute temperature and Q is the heat absorbed. And for a differential change in entropy, we can write the expression like this. Since Q is measured in terms of joules and temperature in terms of Kelvin, The unit for delta S change in entropy is joules per Kelvin per mole. Then the next point is, in case of all naturally occurring processes proceed in a direction accompanied by an increase in entropy. So you can give examples such as melting of ice is a naturally occurring process, the burning of fuel is a naturally occurring process, and the flowing of water downhill is a naturally occurring process. And if you look into all these reactions, definitely the entropy increases in all such reactions. So in all naturally occurring process proceed in a direction accompanied by increase in entropy. That means all naturally occurring processes will move in a direction where there is maximum entropy change. So entropy change is also related to the thermodynamic probability, because increase in the disorder indicates an increased probability. So entropy is denoted to related to the thermodynamic probability. W stands for thermodynamic probability, using the expression capital S is equal to small k natural log W, where small k is the Boltzmann constant and S is the entropy and W stands for the thermodynamic property. Well students, if the question is asked in the examination, write a short note on the entropy. You have to write all these points. The first, you should define the definition of entropy, then state that entropy is a state function, then entropy is an extensive property, and what happens in case of adiabatic process, and what happens in case of isothermal process. You need to write the expression and write the unit of entropy. And entropy in case of natural process is increases, whereas entropy can also be related to thermodynamic probability using the expression. So you have to write all these points for short note on entropy. Now let us understand what is a cyclic process. So after a series of steps, if the system brings back to the original state, then we call this process as a cyclic process. A cyclic process is defined as a process which brings back a system to its original state after a series of changes. You can see the general example here. Initially the system is in the A state, then moves to the B state, C, D, and after a series of changes it will come back to the initial state A itself. Then such a process is known as the cyclic process. Now we know, according to the first law of thermodynamics, that is delta U is equal to Q minus W. Delta U is equal to change in internal energy. U stands for internal energy. So delta U is change in internal energy. Q is quantity of heat transferred and W is work done in the process. Since internal energy delta U is 0 in case of cyclic process, right? Delta is equal to 0 for the cyclic process. Then we have Q minus W is equal to 0 according to first law of thermodynamics, or Q is equal to W. So or we can write Q is equal to W. Now for isothermal cycle, if the cyclic process is carried out at constant temperature, and we call that cyclic process as isothermal cycle. That means if a series of changes are conducted at constant temperature. So well, we know that in case of isothermal process, what is the condition? The temperature is maintained constant. The temperature is maintained constant in any cyclic process, then we call that process as isothermal cycle. If the cycle is in the reversibility is maintained in the cycle, then we call it as reversible cycle. What is reversible cycle? Series of changes are carried out reversibly, then we call it as reversible cycle. Now let us understand what is a heat engine, because in the next topics I have to derive the efficiency of Carnot cycle. Basically the Carnot cycle explains the efficiency of any heat engine. To understand the derivation of Carnot cycle, now let us know what is a heat engine. So heat engine basically absorbs the heat from the source, right? Plus Q2 means the heat engine is absorbing heat from the source. The source temperature is higher, that is T2, and the heat which is absorbed by the heat engine is converted to work whereas the heat which is not absorbed is emitted back to the surrounding. It is left to the surrounding. Minus Q1 represent the heat is liberated by the heat engine. Now, so Q2 minus Q1 is equal to W. So that is the amount of work done by the heat engine. So this block diagram will explain basically how the heat engine is going to work. So heat engines are the engines which absorb heat from the source or heat fuel can source of heat. The heat engines are the engines which absorb heat from a source of heat, that is fuel, and convert part of it to the heat and reject remaining heat to the surrounding. So of course all heat is not absorbed by the heat engine and some amount of heat is absorbed by the heat engine. The heat which is not converted to work is expelled or given out to the surrounding. Now the simple example for the heat engine is a steam engine. A steam engine is a typical example of the heat engine. It takes heat from the boiler. The boiler is the source here, that is high temperature source T2, and converts some heat to the work and returns the unused heat. The heat which is not used, the heat which is not converted to work is left to the surrounding, that is low temperature source, that is T1 is the low temperature source. Well students, let us come to the examination corner. So these are all the possible questions and repeatedly questions asked in the examination. What is meant by entropy is a 2 marks question. For this you have to define what is entropy. So definition of entropy is a measure of randomness or disorder of the system. Then the second question is write a note on the physical significance of the entropy. So this is a 3 or 4 marks question and you have to write all the related points of the entropy along with the definition. You should define what is entropy and say that it is a state function, it is an extensive property, what happens in case of adiabatic process and what happens in case of isothermal process, and you should relate thermodynamic entropy with the thermodynamic probability. Entropy should be related to thermodynamic probability, and all these points have been discussed in the video. You have to write all the necessary points for this question. Then third question is what is entropy? How does the entropy change in a irreversible process? So this is a reason giving question. You know what is entropy is, you should define what is the definition of entropy. Whereas in case of irreversible process, the entropy change is always maximum. So well, we know all naturally occurring processes are irreversible process, and in case of irreversible process, the entropy is always maximum. And the fourth question is define a cyclic process. So will be a 2 marks question. You should write a block diagram and define what is a cyclic process.